Here's problem 32.2. The switch in the figure is closed at t equals 0 when the current I is 0. When I is 15 milliamps, what's the potential difference across the inductor? Okay, in general, our current is equal to our maximum current times 1 minus e to the negative t over tau. And our maximum current is equal to the voltage divided by the resistance in the circuit. So in this case, that would be 240 volts divided by 4,000 ohms, and so that would be 0.06 amps or 60 milliamps. So our current for all time is looking like this: 0.06 amps, 1 minus e to the negative t over tau. Alright, nice to know. Now we're told that when the current is actually equal to 15 milliamps, we want to find the potential difference across the inductor. So at that point, our current would be 15 milliamps. If I can get this to right. And that would equal 60 milliamps, 1 minus e to the negative t over tau. And so we'd have 0.015 divided by 0.06 is equal to 1 minus e to the negative t over tau. So this is going to be 1/4. So we have e to the negative t over tau is equal to 1 minus 1/4 or 3/4. So at that moment, the exponential term is going to be 3/4. Our voltage across the inductor is equal to the voltage of the battery times the exponential term, e to the negative t over tau, in general. So in this case, that's going to be 240 volts times 3/4, which will give us 180 volts. So the voltage across the inductor at this moment is 180 volts. That's one way to do this. There's a second way we can do this, and slightly shorter in this particular case. If we found the voltage across the resistor at this time, that would be the current times the resistance. And that would be 15 milliamps, 0.015 amps, times 4,000 ohms, and that is equal to 60 volts. By Kirchhoff's law, the voltage across the inductor should equal the voltage of the battery minus the voltage across the resistor. So that would be 240 volts minus 60 volts gives us 180 volts. That's sort of a roundabout way of getting the answer, and maybe not quite as instructive as the first way, because the first way is more general for this kind of problem. But it's a different way, and it gives a check of the right answer. 180 volts for the voltage across the inductor.